Please.
This lab is very simple to understand, and I felt like we could do more next time. So I did mine with Jordan Connolly, and he stole the lab sheet, so I'm doing this. And for our lab, basically we took a Kleenex box and we slid it down a ramp, and then we found the coefficient of friction for the Kleenex box. Then we covered it with with other materials like aluminum, saran wrap, what else? And wax paper. And then we tried to guess which one would have the highest coefficient and then the lowest coefficient. So for the equipment, we just use basic stuff, except for the interface, because that didn't work the first time, and then we had to get a new one, the one with the touch screen, and it was really confusing. So basically we had a ramp, and slid down the ramp, took the distance, like distance versus time, position versus, the same thing, velocity versus time, and acceleration versus time. And we don't really have any graphs because it's just a bunch of numbers. So we looked at the log of pro graphs and we determined the acceleration for each material. And this is apparently the constant acceleration, because then if it's changing, it's really hard to do equations and stuff like that. And then the height is this part of the ramp. So I guess
The vertical.
Yeah, the vertical height, because we had to solve for the coefficient two different ways. So we have this thing. So this is the height, and then I'll pull up the data table, which shows all the numbers, and it's kind of ridiculous. So basically, we used two different types. One is MIA, and we use, I'm not going to derive it because that's probably going to take more 5 minutes. So we basically use the final velocity in 1/2 mv squared, and then we made that equal to the mgh. And then that's helped us solve for the fk, and then fn is always mg cosine theta. I think that's right. And so we had that constant for both ways. And the other way is net force. And using the net force, we had the net force in the x direction, which was the constant acceleration plus the coefficient of, like, minus the coefficient of friction. So we solved that for all the numbers, and then we figured out that, I think this is the right data table. Just kidding. Let me close this. Chemistry lab. Okay, here's the real data. So we basically found out over here that the Kleenex box actually had the lowest mu-k, and it slid down really, really fast because it was a brand new one from Schnucks. It was like really sleek cardboard plasticness, and it just went down really fast. And the one that slid down the slowest is the aluminum?
What?
I'm not sure if I'm right about that. Let me check.
I thought this wax.
We guessed that the wax paper would have the lowest and the saran wrap would have the highest, and the saran wrap ended up getting the highest. And then just the Kleenex box got the lowest. And basically, we had a few sources of error. Like, when we slid down the wax paper box, it actually rotated as it slid down. So that would be a really cool lab.
Yeah.
Why does it rotate while it slides down something? But for other sources of error are like air resistance, but we got pretty close to what the actual numbers are. So we found the coefficient with aluminum on wood, and we compared that to the one we got, and it was 4.1% error. That's pretty good. And the problem about this lab is that we didn't really think about it when we were picking the materials, because if you look online, you can't really find saran wrap on wood. Like, it didn't show up because nobody actually does the slab, I guess. So we had a lot of like Teflon on Teflon. Couldn't get Teflon. So basically that's it.
Questions for
Most
Sean?
of the time.
Did you use the Kleenexes at all?
I think we did, yeah.
After crying, but
They were quite cheap, so.
After crying
did you like have a tissue hanging out of it when you went it down? Like was it open?
No, it
So
was-
there's
it was
no,
brand
like,
new.
air
Did you put a little
resistance?
air resistance?
Just write it up in it.
Where did you get the ramp?
We stole your wood.
Oh,
Like,
yeah.
we got a, we got like a board from your basement, and then we
Okay.
put, yeah.
You should definitely thank your
Yeah.
people who've
Thanks to
hanged
Will
out. Yeah.
for donating the board.
Excellent.
That we returned.
Consideration.
No, it's still at Jordan's house.
Oh, okay. So we have it returned.
Thank you, Sean.